Yes, good evening, students. Am I audible? Hello. Okay. So we'll start it in 5 minutes because only 22 participants I can see in the meeting. So we'll start it in 5 minutes.
Start Zoom meeting.
Yes, good evening, sir.
Good evening. Good evening. Yeah, so we could begin now.
Yes, yes, just a minute. I think I should have to give the access to you. Let me give the access. Yes, you can start, sir.
I hope everyone can see my presentation.
Yes, yes, it is visible, sir.
Okay. Good evening to everyone. And thanks to Garware College for and all the faculty members of Garware College for this opportunity. And thanks to everyone who has joined today. So the lecture series is on AI applications and threats. Myself, Pranav Marathe, and my colleague Yogini Burde would be conducting these lectures. So today's lecture I would be conducting, and subsequent. So we'll be sharing those lectures between us. So topic is again AI applications and threats. And today the first lecture I would like to cover some foundations and historical context of it, because to understand AI applications and threats, it's necessary to understand certain background concepts or basic concepts around AI. And I'm sure you would have got in touch with AI in one way or the other, because there are very few in today's time who haven't, and you would have probably got some knowledge about it. But let us cover all the basic concepts and the foundations of AI, so that the applications and threats would be eventually clear, right? Okay. So just quick introduction about myself. I have around 2 decades of experience in across industries into various roles, be it automobile sector, renewables, IT, primarily in program management roles and PMO. So I was heading the PMO at Kirloskar Group, Renewable Energies company group, and so now I'm associated with Rian as well, with the project management office there, and which is again connected to AI. So this is a brief introduction of myself. I'll just continue with the presentation now and switch off the video. Okay, so since we are representing Rian, I would just like to cover something about Rian, what Rian is, right? Rian is a cloud-based translation management system, and it's a computer-assisted translation tool that transforms video and document localization for the media industry. So basically, what Rian does is translates document into various languages. I think it's 60 odd languages any document can be translated into, and video localization is complete translation of a video, including its experience. So it's not literal translation. Okay. So lip sync, uh, the lip sync of the video. Okay, how the people talk, the exact, the emotions in the audio and everything is captured. So that is why we call it localization of a video. So you won't be able to actually distinguish the original video from the translated video. I'll show you a video to you. So this is what Rian is, a translation tool and a translation management system, and which heavily is into AI to make this happen. And so this is how Rian is connected with the AI. So all the localization tools and techniques and the workflow for document as well as video localization is done through AI tools. And that is how Rian is actually one of the very few worldwide who does localization to this level of accuracy, or this level of deep kind of a localization, that the original content, especially in videos, cannot be distinguished from the translated one. You can also visit the website whenever you would like to and have a look there. I'll just show you a sample video to start with. Everyone is aware, or everyone knows Sanjeev Kapoor, right? The chef, celebrity chef. So let us have a look at his video. I hope everyone can see it and hear it as well.
नया साल आते ही कितनी उम्मीदें बढ़ जाती हैं, सब कुछ नया करने का।
Just a question again, can you hear the audio as well?
Yes, sir.
Yes, sir.
ऐसा लगता है कि
So this
नए
is the
साल के
Hindi
साथ
one.
में नया जोश अपने आप आ जाता है। As the new year approaches, people's expectations increase. We feel like doing something new. It seems that the new year brings new excitement and enthusiasm on its own.
Could you actually distinguish between the two videos? Actually, the English one was the translated one, right? So the original was Hindi, and you could see the absolutely similar ones, right?
Approaches, people's expectations
You can't
increase.
actually
We feel like
distinguish between the two, right? So this is the level of localization which Rian can do. So this was just a glimpse of Rian. I also thought that, before I start my presentation and the slides, um, AI should be explained kind of through visually, I mean, through a video. So I found a good video which I would like to run initially so that you understand what the various concepts are, how they are connected. Because AI, as you can see, is a way of the computer mimicking a human being, right? So somewhere म्हणजे आपण काय करतो याच्यात की फॉर दोज हू अंडरस्टँड मराठी आय होप मोस्ट ऑफ देम डू वी वॉन्ट टू आपल्याला मशीनची कॅपेबिलिटी आहे जी कॉम्प्युटरचे वी वॉन्ट टू टेक इट टू द ह्युमन लेवल अँड प्रॉबेबली बियॉन्ड राईट सो इट्स समवेअर कनेक्टेड विथ द ह्युमन एक्सपिरियन्स ऑल्सो so if we understand AI from that perspective through this video, concepts will be clear. So just I'll play this short video and then we can go through the slides.
Artificial intelligence for people in a hurry. The easiest way to think about artificial intelligence is in the context of a human. After all, humans are the most intelligent creatures we know of. AI is a broad branch of computer science. The goal of AI is to create systems that can function intelligently and independently. Humans can speak and listen to communicate through language. This is the field of speech recognition. Much of speech recognition is statistically based. Hence, it's called statistical learning. Humans can write and read text in a language. This is the field of NLP, or natural language processing. Humans can see with their eyes and process what they see. This is the field of computer vision. Computer vision falls under the symbolic way for computers to process information. Recently, there's been another way, which I'll come to later. Humans recognize the scene.
Pranav sir,
Yeah.
yeah, just a minute. Can you just pause that video?
Yeah.
Yeah, just a minute. तिथे ना होस्ट केलंय मी तुम्हाला, तर तिथे रेकॉर्डिंगचा ऑप्शन तो एनेबल करता का? रिक्वेस्ट होस्ट टू स्टार्ट क्लाउड रेकॉर्डिंग असे आहे, किंवा रेकॉर्डिंग हे करा, किंवा मला को होस्ट ऍड करता येते का?
I'll just check just a moment.
Yes.
Actually, it's showing as resume.
अच्छा, recording is going on then.
It's already in progress.
Okay, fine.
Yeah.
No problem. ठीक है. Yes,
Okay.
continue.
This field of image processing, which even though is not directly related to AI, is required for computer vision. Humans can understand their environment and move around fluidly. This is the field of robotics. Humans have the ability to see patterns, such as grouping of like objects. This is the field of pattern recognition. Machines are even better at pattern recognition because they can use more data and dimensions of data. This is the field of machine learning. Now let's talk about the human brain. The human brain is a network of neurons, and we use these to learn things. If we can replicate the structure and the function of the human brain, we might be able to get cognitive capabilities in machines. This is the field of neural networks. If these networks are more complex and deeper, and we use those to learn complex things, that is the field of deep learning. There are different types of deep learning in machines, which are essentially different techniques to replicate what the human brain does. If we get the network to scan images from left to right, top to bottom, it's a convolution neural network. A CNN is used to recognize objects in a scene. This is how computer vision fits in, and object recognition is accomplished through AI. Humans can remember the past, like what you had for dinner last night. Well, at least most of you. We can get a neural network to remember a limited past. This is a recurrent neural network. As you see, there are two ways AI works. One is symbolic based and another is data based. For the database side, called machine learning, we need to feed the machine lots of data before it can learn. For example, if you had lots of data for sales versus advertising spend, you can plot that data to see some kind of a pattern. If the machine can learn this pattern, then it can make predictions based on what it has learned. While one or two or even three dimensions is easy for humans to understand and learn, machines can learn in many more, like hundreds or thousands. That's why machines can look at lots of high-dimensional data and determine patterns. Once it learns these patterns, it can make predictions that humans can't even come close to. We can use all these machine learning techniques to do one of two things: classification or prediction. As an example, when you use some information about customers to assign new customers to a group, like young adults, then you are classifying that customer. If you use data to predict if they're likely to defect to a competitor, then you're making a prediction. There's another way to think about learning algorithms used for AI. If you train an algorithm with data that also contains the answer, then it's called supervised learning. For example, when you train a machine to recognize your friends by name, you'll need to identify them for the computer. If you train an algorithm with data where you want the machine to figure out the patterns, then it's unsupervised learning. For example, you might want to feed the data about celestial objects in the universe and expect the machine to come up with patterns in that data by itself. If you give any algorithm a goal and expect the machine, through trial and error, to achieve that goal, then it's called reinforcement learning. A robot's attempt to climb over the wall until it succeeds is an example of that. So there you go. Thanks for watching, and if you like my videos, please subscribe.
Right. So I hope a lot of things were clear from this overview of AI. Basically, how it is connected to the human experience is, that way we can understand the concepts better. So let's now move to the slides. Okay. So introduction. Basically, what is AI? Or artificial intelligence. It refers to simulation of human intelligence, right? So how the human brain or how the human intelligence thinks, to simulate that in machines is called artificial intelligence, right? These machines are programmed. So how will you simulate? So how will you simulate human intelligence in machines? Through programming. So these machines are programmed to think like humans and mimic their actions. So that includes human behavior, human senses, human way of thinking, and also traits associated with human mind also, how the mind works. Okay, in terms of problem solving, looking at problems, right? Tendencies. So all these things come as a part of AI. The complete human intelligence includes all these aspects. So fields of AI have subfields again, like what we saw in the video also, machine learning. So what does machine learning do? It enables computers to learn from the data given. Basically, how will a machine learn, or how do we learn actually? We learn from data, right? Our experiences are nothing but data which we are receiving. So if we provide large amount of data to machines, the machines will and computers will also learn. That is called machine learning, robotics. So what does robotics involve? It involves robots to perform tasks effectively and autonomously, both, so on their own, right? So robotics has two aspects to it: to do tasks perhaps as good as or exceeding human capacity in terms of speed, accuracy, etc. So now robots are used to even do surgeries, right? And do complex surgeries which perhaps human doctors won't also be able to do. So exceeding human capacity and autonomously, they should be able to operate on their own. So this comes under robotics. Natural language processing. when the machines interact with human beings, they should have the capability to understand human language, right? So it can't be always, you can't communicate with a computer always in a coding language, right? Or always in a program. The human language or human expression needs to be understood by the machine. So that is called natural language processing, allows the machine to understand and interact with human language. And then computer vision. Um, the computer vision enables computers to actually understand visual data and interpret visual data, like you have seen image recognition, right? So uh, or pattern recognition, the computers actually can understand the image and interpret and make decisions based on the visual data like images and videos. So that is called computer vision. So these are the subfields of AI. And so basically, how did this start, or when did this start? We'll actually look at something historical about AI, but basically the acceleration of development has come over many decades, and it came, I think, around 1950s. The concept of AI came, and then gradually it has come to the point which we see today, that AI is almost everywhere. This also came through because not only with the evolution of concepts and ideas, but with the evolution of computing power also, because AI requires a lot of computing power. So with the development of computers and computing power and technology, AI development of AI also has accelerated over the last few decades. Just give me a moment. Okay, so why is AI important? I mean, why should we study or have a look at, or why are we having this discussion itself? Because has a transformational impact. So if you look around, AI is transforming everything we are doing, right? So transforming industries. Today, every industry has automation. Every industry or many industries have robotics, and many industries have analytical tools, AI-based analytical tools. So many of the tasks are becoming automated even in the IT industry. So many, so across industries, there I think there will be very few industries where AI has not reached. So that is why we are today discussing and understanding what AI is about. So to understand the concepts and actually uh, to not only to use it effectively, but maybe go deeper and be a part, or maybe play a role in actually developing something or be a part of the AI ecosystem as a whole. So now, see, across industries, so healthcare also comes in as an industry. So diagnosis of diseases, like I had given an example of performing surgeries, be it the finance sector, predictive analysis, anything, everywhere AI is involved today. So it has completely, or rather, it is rapidly transforming, you know, uh, the way we are operating across industries. Again, a few examples. You must have been using Siri and Alexa or the self-driving cars, right? Self-driving cars are completely AI-based. Um, then you must have used those platforms like Netflix and Amazon, right? So Netflix and Amazon आपण जेव्हा वापरतो तेव्हा आपल्याला recommendations मिळतात, right? So it understands what we like to see, and then it gives recommendations as to what we should be watching. So even on Amazon, it recommends based on our previous preferences as to what we should or what we would prefer, and it shows those things to us, what, and it suggests what we should buy, right? So all this everything involves AI. So understanding this is relevant in today's, not only for using it effectively to simplify our task, but also in the evolving job market, which is something uh, which you would also be very much interested in, right? So to acquire the crucial or important skills in AI and understand the opportunities that are there today. Of course, those are rapidly evolving as well. So the technology is transforming rapidly. New roles are coming in with respect to AI, new job opportunities in AI. So everything is currently in a rapid transformation stage. So that is why we need to understand it. So what exactly AI is made of? When we say AI, what does it involve? So it has multiple parts to it, right? One is the software part. So we have programs and algorithms. Basically, in AI, we are trying to program or give instructions which mimic human intelligence or behavior. So one part of it is the algorithms or the set of instructions. Then it's the natural language processing program which can understand the human language part of it, right? So which can understand and interact with humans. So those category of programs. Then the computer vision software, which allows AI to interpret the visual data. Okay, so software and programs and algorithms are one part of AI. Second is the big data, huge data. Say for example of consumer preferences. We were talking about Amazon. So a huge data is generated as to what consumers prefer. So when Amazon is giving you recommendation as to what to buy, it has your data, right? It has your data with it, and it is then recommending you based on that data. So huge data is being generated, which is called big data. So that data allows AI to recognize patterns, identify trends, analyze that data, and make decisions. So data is an important part of AI. Now it is labeled and unlabeled data are two categories of data in which we'll have a look at that, in which supervised and unsupervised learning happens. Which so actually the AI system, we can say the entire system learns from the data as to progressively improve upon the task which it is doing. Then the hardware part of it, right? So process the software, we need hardware. So the processors, so CPUs, GPUs, uh, significantly powerful CPUs and GPUs are required to process the AI software. Then the storage system where the data is actually stored. So we need to store that data, right? Somewhere. So the storage systems. And there are some specialized software like transfer processing units, customized hardware, which is customized for AI related tasks and machine learning models. So then the third category is hardware. Then the human expertise, like data scientists and engineers who actually build these systems, program, make the programs and softwares, and are experts in programming, statistics, domain knowledge, etc., which are who are actually enhancing these systems or operating these systems. So that is the human experience. And then the ethics and regulation. There are frameworks and guides, the framework that guide the development and deployment of AI systems, right? So everything should operate within the bracket of ethics and regulations, which are laws, right? So then these laws and ethics govern how we use all this. So where we apply AI, where not to apply AI, how to store data, what is the data security standards required. So all these rules and regulations also are a part of the AI system. Okay, so AI is composed of all these things. So if we again ask the question, what is AI made of? It is made of software, data, hardware, the actual human expertise, and the ethics and regulations. All this form AI together. Now, if we look at the history, when did this probably start or come up as an idea? In the mythology, or if you look at the ancient stories or ancient records, normally the imagination was, or we don't know, perhaps the observation was, if something was developed like they say in those eras, that some automated machines, some intelligent weapons, right? Some artificial beings. We can, in the mythology and the ancient texts or stories, we often come across such kind of ideas. So probably the idea of an artificial being or an artificial intelligence intelligence which created by humans, which can actually mimic or can be better than a human. That idea can be still seen in historical text itself, right? And mechanical devices, some equipment which created unbelievable results or automated results or something which human can't do, something which has exceeding capacities than human being. So these ideas were existed right from the historical times. But then in the modern times, like I said in 1950s, uh, there was a conference called Dartmouth Conference in the US where this conference was the objective of this conference was to explore the possibility of creating machines that could actually simulate intelligence. It is widely considered that this conference was a significant event in actual considering AI as a formal discipline or actually an idea which can be worked upon, progressively worked upon. So this conference has that significance because many important people who have contributed a lot towards AI were present in that conference, and this led to establishment of research groups from which the actual development of AI and AI started. So this can be considered as a significant event in modern times, we can say, for the start of AI development. These are the names of a few people who have contributed significantly to the field of AI. Uh, Alan Turing was also yeah, is considered to have contributed significantly. He was a British mathematician, logician, and cryptanalyst, and he actually created the Turing machine, which is actually a device which has symbols and a strip of tape, which actually manipulates the symbol according to the rules which we can give it. So the Turing test, which was conducted in 1950, what was the test? That if a human judge cannot reliably tell a difference between a machine and a human being during his interaction, the machine would is said to have passed the test. So the machine is performing almost equivalent to the human being, so that it is indistinguishable, right? So this was the Turing test. So his ideas and remains central to many of the concepts which have come up in AI. So Alan Turing is considered to be a visionary and as a significant contributor in the development of AI. So these are some of the early AI programs. Logic Theorist was the first AI program designed to mimic problem-solving abilities of a human. Okay, it had various theorems demonstrating that the machine could actually perform tasks requiring human-like reasoning. So, and then the general problem solver in 1957. It was designed to solve a wide range of problems using a general method. At that time, the computing power was limited, but they did attempt to develop this problem-solving program then, which actually is considered a significant milestone. Then there was ELIZA. It was an early natural language program, a processing program that actually simulated a conversation with a human. So look at the dates; they're considerably these are right in the 50s and 60s, right? So it was quite. It has been so look at when it started. Quite some time has passed. Till it has now reached this stage where it is a part of our daily life. Right? Okay, so we have looked at what we have just looked at what algorithm, the software part of the AI, right? It consists of programs and algorithms. So what is an algorithm? So algorithm is a specific set of instructions which is designed to perform a task or solve a problem, right? So algorithms are considered the fundamental building blocks that allow machine to process data. So those are a set of instructions which tell AI what to do, right? So which are a part of AI. So like a part of human thinking, the human reasoning. There are some inbuilt programs which go on in human intelligence, right? So these, like, they are a part of human intelligence. The algorithm is a part of the AI. Algorithm form the foundation. It forms the foundation of AI systems, enabling to carry out tasks. How they react to the data, how they analyze the data, how they see patterns. So all this comes from instructions. So algorithms are part of it. So there are a few types of algorithms, sorting algorithms, like used to arrange data in a specific order, such as alphabetical sorting or numerical order. Search algorithms find specific data within a huge data. They find so from a huge data set, they can find and pick up the data which we would like to find, search for. So they are search algorithms. Decision tree. So decision tree is like a flow chart, a flow chart like structure. So each node on it is represents as a test point on an attribute. So as an example, whether a customer is over 30 years old is a criteria. So that one node represents that particular condition, and each branch represents the outcome. Each leaf node represents a decision or classification. And so these are widely used in classification tasks where they help to predict the outcome based on specific inputs. Then the neural networks. Like what we said, the AI is trying to replicate the human brain, right? Which is considered to be an absolutely amazing machine, and we are just about not even close to in terms of the complexity of the human brain, but through neural networks we are trying to get there, right? So inspired by the structure of the human brain, how the neurons in the brain work. So basically, neural networks mimic the way the human brain functions and consists of layers of nodes or neurons that process the information. Now, what are the nodes? They are actually a mathematical formulation. So the particular mathematical condition or a formula represents a node or a neuron or overall neural network, but which mimics how the human brain works or the neurons in the human brain work. Genetic algorithms are based on the principles of natural selection and genetics, and they are used to solve optimization problems through to actually optimize a solution. So if there is a pool of potential solutions, if there are 100 solutions through which we are want to optimize a particular solution, then the genetic algorithms are used for natural selection and optimize which solution to reach the best possible solution from that pool. Now, the data part of AI, why it is crucial. Whatever an AI comes up with, see, for example, the decisions or recognition of patterns or understanding human inputs through natural language processing, everything is data, right? What flows in and what flows out, everything is data. So data is like a lifeblood of AI. So the huge data sets, which actually gives you recommendations on Amazon, again, is the base of the functioning of the AI model in that particular application, right? So data is like a lifeblood of AI, which so data input and output and the process, everything is being done on data, right? So types of data, structured data, which is organized data, which is found in databases where information is stored in proper structured format in say rows, columns, etc. Right? So customer information, transaction records, inventory data, whatever is stored properly is called structured data. Unstructured data that is not organized in a predefined manner, such as text, images, and videos. So it is a bit randomly stored. So it is more challenging to analyze it, but it is very important for AI applications to actually process, because a huge amount of data comes under this category. Not all data is always structured data, right? So unstructured data is something which an AI model will come across in many instances. semi-structured data, so which does not fit into traditional structure format, but has some organizational properties like JSON files or XML files. Semi-structured data is often used in web applications and data exchanges. Then big data. So big data refers to extremely large and complex sets of data, right? So like for example, we discussed the consumer behavior. So imagine the data generated from a platform like Amazon across the globe, right? So how large that data set will be, or data on financial transactions across or across nations or across the global economy, etc. So huge data sets and complex data sets is called big data. And so there are two aspects to it. So big data is required to be analyzed, and some patterns needs to be found out, and a decision will be reached. So it needs to be transformed into usable form. Like for example, giving recommendations to consumers. And secondly, the AI system actually learns from this big data. So repeatedly recognizing the patterns, recognizing the various parameters, the repetitions in the data, the numbers in the data. So all this trains the AI to get better. So big data is very much essential for both these aspects, because a lot of data is actually in the form of big data, which needs to be processed by the AI. And secondly, AI actually learns from the big data and gets better. So how does the AI actually get better? That is through learning. Like a human being learns, the AI also, since we are again mimicking a human experience, we want the AI to learn as well, right? So, and to get better. So learning in AI refers to process by which an AI system improves its performance over time through experience. So what does this involve? It involves processing of data, recognizing patterns, and making decisions or predictions based on past experiences. If anybody of you have been using AI tools, there is a vast or absolutely huge amount of improvement, especially if you have used some image generating tools, or AI image generating tools. There is a huge transformation into what the current tools can do than the previous one. So in addition to the actual program evolution, or the hardware evolution part of it, or the software one, the training part of the AI has played a lot of experience. Now image recognition has also become so much more accurate than it was what it was previously through this learning. So supervised learning, unsupervised, and reinforcement learning are three types of learning. In supervised learning, the data is labeled, into categories, and the AI is given the data with the labels, and then it is trained on it so that it understands that this particular data is under that particular a particular label, so that it now knows the data with the label which we have given it. So in a way, we have given it already classified data or labeled data to understand from. So that the correct output is known to the AI through this data set. Then unsupervised learning is in which the AI is left to explore on its own without specific labels or instructions. So it itself needs to find patterns and relationships on its own. So it is a bit complex and a difficult or a complex learning that compared to supervised learning. And then there's the reinforcement learning, where AI learns by interacting with its environments, and where a reward and penalty system has been introduced. So the aim of the AI in reinforcement learning is to gain maximum rewards while performing a particular task. So, uh, so uh, that enables the AI to find the optimum solution or the most effective solution, so that it will gain maximum reward from the task and avoid penalties. So this is called reinforcement learning. Okay, so a quick look at supervised learning, in which the AI is given data which is labeled. And so this means that each example in the data set includes both input data and the corresponding output set. The model learns to map the inputs to the correct outputs and can make predictions on new unseen data. So, for example, if we give the AI pairs of images called labeled as cats and dogs, it learns to predict. So if you now label a cat and dog and give AI enough pairs to have to look at, and then if you give a new image to the AI, it will be able to identify whether this is a whether that new image is a cat or a dog, because you have already given numerous such examples to the data to the AI with the labels on it. So now it knows overall what a cat looks like, or a dog looks like. So if you give a new image, it will be able to understand. So applications are in handwriting recognition. If AI is trained on enough variations of handwriting, or enough variations of handwriting of a similar pattern or of different patterns, it can then recognize whether that handwriting is of a particular person, right? So if you give it enough samples, then it can actually match the pattern. Or speech recognition. This is called this. All this comes under supervised learning. So we'll exclude the details like the algorithms used for now, because we are just basically understanding the foundations of AI. So the advantages of supervised learning is it is highly effective because labeled data. One is that the data is labeled. Secondly, there's an abundant labeled data which can be used to actually train the AI, and it is very effective because you have already classified the data for AI. Limitations are you have to generate that label data, right? So somebody has to make a classify or prepare that label data which can be actually given to the AI, which is time consuming and probably expensive also so that is the limitation of supervised learning. And if some larger variation comes, then probably the supervised learning would fail, because something completely new, uh, if something completely new comes, then the AI won't probably be able to classify it uh, under a particular label given. Right? So there's a limitation to what comes under a particular label, and the number of and how the AI works over. So something completely new will come outside a particular label, and it will be difficult for an AI to identify. Unsupervised learning is where a model is trained on a data set without label. So it's on its own, right? So the AI on its own needs to explore the data, understand the patterns, and understand the clusters within it, and make groups according to the similar behaviors or similar patterns, similar characteristics. So so normally, unsupervised learning is used to make clusters, that is groups, which show similar patterns or find something which is abnormal, like anomaly detection. Like say, for example, fraudulent transactions in the finance system. So if it can identify something which is abnormal because it has mapped what is normal. So it has mapped enough clusters or patterns so that it can immediately identify something which does not match to it. So this is unsupervised learning. Since it doesn't have any labels attached to it, so it is it can be a bit unpredictable at times and harder to evaluate. And at times it requires more to interpret. It requires more effort to actually interpret the findings, because the AI is evaluating the patterns on its own, right? So there are no labels attached to it, or there is no human intervention yet. So to actually understand the classifications or the findings which AI has come up with can be a bit challenging here. But unsupervised learning has many important applications, uh, like wherever pattern recognition is there. So market segmentation, where customers are grouped. So wherever grouping, clustering, pattern recognition applications are there, uh, unsupervised learning is very effective. Then reinforcement learning, where the AI interacts with the environment and it receives reward or penalties based on its actions. So the classic example is if there is a maze, hmm, and there is a single way or a couple of ways which take you to the final destination, and in between there are obstacles. Okay, so and the AI needs to find the right path through the maze. So for every correct turn taken, if the AI is given a reward, and for every wrong turn taken, it is given a penalty. So in such a scenario, the AI will find an optimum way to reach the final mark or final destination and to receive maximum rewards, right? So to make the least errors and take the right decisions to achieve the final target. This is also when AI is trained to play games, like for example, like chess or Go. Go is also a popular game which AI has actually competed with the best players in the world and has won against them. So this is reinforcement learning in which there is penalty, a reward and penalty system. Now neural networks. We saw that we want AI to mimic human brain. So in a human brain, there are neurons, or there's a network of neurons which actually functions to process the information and to take decision, process the data, everything. So in neural networks, this particular structure of a human brain is actually mimicked. And so in that, how is it actually mimicked? It is through mathematical models and programs, which typically mimic the way the neural network works. It has various layers. So there's an input layer which receives the raw data. Then there are hidden layers which perform the computations on that data, extracting figures, learning patterns, etc. And the output layer which produces the final prediction or decision. So neural networks are widely used in image recognition, identify objects in photos, speech recognition, and natural language processing. So how does the neural networks actually learn? So your neural network learn by adjusting the weights of the connection between neurons. So as you might be knowing, two neurons in the human brain actually communicate with each other through electrical impulses. So similarly, in neural network in AI, there are connections between those programmed neurons and by adjusting the weights of the connection between neurons through a process called backpropagation. We need not go deep into this as of now. Where the neuron is corrected based on the error it makes during training. Over time, this allows the learning process and improve the accuracy. So there are mathematical functions applied to the output of each neuron in the network, and there are multiple examples of this. We need not go deep into those functions as of now. And the process of training the neurons involves feeding the network with input data. So some data is input to the network, calculating the output, and then comparing it to the desired result. And when you compare it to the desired result, you again make some adjustments so that you continuously improve in getting the desired result. This is how the neural network is trained. There is a concept called deep learning. You must have heard of it. So, neural networks with multiple layers is referred to as deep neural networks, which are the basis of deep learning. So, deep learning has led to significant advancements in AI. Image and speech recognition capabilities have come up through deep learning. So, uh, deep learning can actually do any advanced tasks like image and speech recognition. I think not mute themselves. Can everyone please mute themselves so that others hear? So if we compare the neural networks to the human brain, basic inspiration is how the human brain structure is there, right? So we want to do the same in AI, reproduce it, make something identical, and probably something which will function better than the human brain. So if you talk about the structure, while the human brain has billions of neurons connected by trillions of synapses, a neural network has comparatively simpler structure of artificial neurons, but the principles of signal transmission and learning are something which are similar to the human brain. And like we said, like we looked at the learning process through back propagation is also something which is something which is similar to what goes on in human learning. So we want to mimic the human learning process also in neural networks. Okay, we'll just briefly go through these aspects. Convolutional neural networks. So what are CNNs? Convolutional neural networks are a type of deep neural network designed for processing structural grid data, like images, which have a particular grid type structure. So these are effective in visual recognition tasks. So CNNs are better in the tasks which are related to visual recognition due to their ability to automatically and adaptively learn the spatial hierarchies of the features. So basically, it understands the images and wherever grids are involved very effectively. So it is widely used in visual recognition applications. So how do they work? So CNNs use a combination of convolutional layers or pooling layers, what we call them, and fully connected layers to process the images. They identify and learn features like edges, textures, and then the features of the images to actually identify what the image is about. So where are they used in image recognition, object detection, facial recognition? So various companies use these networks in their applications. Now, the recurrent neural networks are a type of network designed for sequential data, such as time series or text. Wherever data is sequential, they are useful for tasks where the order of data points, the sequence of the data points, how it is arranged is important. So, so these have connections which loop back on themselves, allowing them to allowing information to persist across time steps. So this networks are suitable for tasks like language modeling, where understanding the context provided by earlier words is crucial. So by what do we mean by understanding the context? It means that the language should not be understood just literally. The model needs to understand what is being communicated here beyond the words, like the context, what is being said. So the same arrangement of words can mean something else, right? But the context in the communication should be understood, what is being talked about or what is being communicated. So that is where the recurrent neural networks come in. Now, what are the limitations of neural networks? What goes on within, especially in deep networks, it is difficult to easily understand or interpret how a specific decision is being arrived at. So this lack of transparency is a particular drawback because the decision making process needs to be clearly understood. So in complex or deep networks, sometimes the transparency as to how the mechanism is working to arrive at a decision is a bit vague or it is not understood clearly. Second is data dependency. Neural networks require vast amount of data to perform well. So without enough data, they can easily overfit to training data, meaning they perform well only on known data, but poorly on unseen data. So larger the data, the neural networks will perform better. Computer intensity. So training deep neural networks is a computationally expensive, right? So it requires significant processing power and time. This can be a barrier for smaller organizations or projects with limited resources. Okay, deep learning. So what is deep learning? We just touched the topic. So deep learning involves training neural networks with many layers. So multiple layers of neural networks are involved in deep learning. And these networks are capable of automatically learning to extract features from raw data, making them particularly powerful for complex tasks like image and speech recognition. So deep learning has a complex structure to perform complex applications and especially in image and speech recognitions. So through deep learning, we have developed some significant advancements in AI in the past decade, like computer vision, speech recognition, natural language processing. So basically, it's closer to mimicking a human brain through deep learning and having the ability to perform those complex applications. If you look at the image recognition systems like Google Photos, voice assistants, etc., there the deep learning is involved in these kinds of applications. Okay, how does deep learning differ from traditional machine learning? In machine learning, feature extraction involves transforming raw data into input variables that model can use to make predictions. So this is done manually. Okay, so requiring domain expertise. But in deep learning, the network automatically extracts features from raw data through multiple layers. Okay, so the raw data is automatically analyzed in case of deep learning, uh, enabling AI to actually learn the complex pattern directly from data without any intervention or without any doing anything manually. So this is how the deep learning differs from traditional machine learning. Then the performance with big data. Traditional machine learning models may struggle with very large data sets. Often, so we need many times we need to actually reduce the data for traditional machine learning. But for deep learning models, actually perform better with larger data sets, making them ideal for big data analytics. Computational requirements, of course, deep learning requires heavy or computational requirements to be processed than traditional learning because it is basically more complex and more powerful. We have already looked at the applications of deep learning. So it's computer vision, speech recognition, and natural language processing, autonomous vehicles. So wherever complex kinds of applications are required, where big data need to be analyzed and the patterns are to be recognized, deep learning comes in the picture. Now, data is actually the role of data in deep learning is